Okay, so this is a continuation of our discussion. This will be the property of transpose of a matrix, which will be the double transpose matrix. When we say double transpose matrix, that states taking the transpose of a matrix twice returns the original matrix. So there will be this is denoted in this one, A to the power of transpose and then power of transpose. And that must be equal to A. We'll be going to check that later on. How does it work? Then the first transpose of matrix A then swaps its rows and columns. And then the second transpose swaps them back, restoring the original arrangement. So let's actually try to check how does it work then. So here, we'll begin to identify, say for example, that we do have here a certain specific example for our um, matrix, given that we do have this problem. Say for example, let me use a specific example. Suppose that we are given 3 by 3 matrix. So, for example, like that. So this will be our A matrix right now. And the first transpose will be like that. Is equals to, this will be the first row, and that will become your first column. So 661. Then this will be your second row. We'll be going to do that, transpose it into a column. That will be going to happen. And the third column, row, will be going to be like this. Now, this will be your first transpose. Will gonna happen. That's how you will do that. So that's the representation of your first transpose. And the second transpose will be your A transpose. You will transpose this one. You will matter in that matrix. You will be going to transpose this matrix right now. The first row will become like this. And the second row will become like this. And the third row will become like this, which in our definition, it seems that your A transpose of transpose, the first transpose here, that will be the basis of our second transpose. So for your second transpose is actually must be equal to A, as being mentioned in our definition. So let's try to verify that one. 661. Okay, good. In our first row, 694, 694, and 469, 469. So that is really equal. That's why in our double transpose of a matrix, it is second transpose will be equals to your A. So that's it. I'll see you in the next tutorial.